Hi guys, today we are going to look at a very interesting topic known as Memory GPT or MemGPT. This has revolutionized the usefulness of large language models. As we know, large language models have limited context windows. They have revolutionized the AI industry, and because of which this channel exists. But the main problem of the large language models is that they are constrained by their limited context windows, and this hinder in different tasks. But in this paper they have talked about two tasks that requires long context windows. The first is extended conversational agents. You're chatting with the one of the chatbots, for example, and after 10 minutes of chat it doesn't remember the last 20 conversations that it had. It's very frustrating. Document analysis. You have a huge document, an SEC filing or a huge company's report. You want to extract useful information from that document, and your LLM is just not able to take in the entire document as one piece and give you the summary or output. So that is very frustrating. So this paper tries to remove those problems by an innovative solution, and that solution is mimicking the functioning or operating style of the OS or operating system. So it draws inspiration from the hierarchical memory structure of an operating system. It intelligently manages different memory tiers in order to effectively provide extended context. Now, if you see the markings that I've done in this paper, the red one indicates the problems that we have, and the green one, it indicates something positive that is mentioned in the paper. So for example, this red one shows that the widely used open source LLMs can only support a few dozen back and forth messages or reason about a short document before exceeding their maximum input length. Yes, we know that. It has a quadratic increase in computational time and memory cost due to the transformers architecture's self-attention mechanism. Now, when this transformer architecture was introduced, it was a huge opportunity to bring down the cost and time requirement, because the earlier the earlier models that we have in the form of neural nets or other propagation algorithms, those techniques had huge cost. In order to expand to a number of use cases, the computational cost was huge, and it had quadratic increase in computational cost and memory. Transformer architecture brought down the cost, but now with the use and advancement of these technology, even the transformer architecture is getting restrained because of the context length. Now in this paper they have provided an illusion of an infinite context. So the LLM will feel that there is an infinite context and that it can use to run longer term and long duration or longer context things. So if you can have a look at this diagram. So this diagram, you can see inside this shaded component, that is the MemGPT, and we have the user input in the form of message, in the form of document upload or system message timer. So this is the LLM processor, for example GPT-4, Claude AI. So this is the large language model. What it sees that it has a main context of a fixed length. You can see the length of different, for example, different models. For example, this open source model Llama 2 has 4K tokens. We have GPT-4 of 8K tokens, which is about 140 total messages. Or you are having conversation with a chatbot that will be completed in just 10-20 minutes. You have Claude 2, that is a limited API, but it has a token of 100K tokens. This seems large, about 2000 text messages, but this is not even large, because a good book or very large book has context window more than this. Okay, so in this paper, this architecture has been mimicked from the operating system's style. So what happened is that the large language model has this main context, which is the context that we have seen on the table, and it has this external context as well. So when the large language model processes the main context, the output goes to a parser. Now the parser decides the output, whether it is a function call or not. If it is a function call, it has a list of functions predefined and already written by the developers. So those functions, for example, one function could be read from the memory. Other function could be write to the memory. So when we say write to the memory, it means that from the main context and from the output, we see the main things that the LLM feels that it needs to be stored in the long-term memory. It can store in the external context. So it keeps on storing in the external context, and our external context is our hard drive, for example. So this hard drive can store as long as there is space in the hard drive. So in principle, it feels like an infinite memory. So if you can read through this, it says in MemGPT, a fixed context LLM is augmented with a hierarchical memory system. So this is the entire virtual context, and there are functions that let it manage its own memory. The LLM processor takes main context analogous to the operating system RAM. For example, this main context can be treated as RAM, and that is inspired from the operating system infrastructure. This is input and outputs text interpreted by the parser, resulting in a yield or a function call. If function call, then these are the functions that can be done. And then MemGPT uses function to move data between the main context and the external context, analogous to the operating system disk memory. When the processor generates a function call, it can request control ahead of time to chain together functions. What do you mean by ahead of time? It means that if we have a system message, for example, there is memory full, it can have a message, for example, the memory is going to be full, then it can take some actions and store its data in the external context, in the hard drive or the disk memory. Okay, so this is the entire loop. So if we head down and we can see, these are the models we have already seen. This is the max token available, and there are three types of messages. There are system instructions. So these are the base instructions, that are the system instructions for the large language models, and these are the MemGPT functions that have been described and control flow to the LLM. This remains fixed. Okay, conversational agents, this is the first in and the first out. This has a special eviction policy. If the queue reaches a certain size, then the first portion of the front is truncated. So this is the context is divided into these three components. So system is done, conversation is done, and the working context. The working context, it serves as the working memory of the scratch pad for the agent. So the context, when we talk about the context length, it is divided into three components, and all these three components should be within the limits of the context model. So for example, in GPT 3.5 Turbo, we have 4K context. So these three, combining these three contexts, our tokens should be within the allowed 4K tokens for GPT 3.5. So these are the tokens. This is an example where we have MemGPT says, hey Chad, welcome. I'm excited to embark on this journey with you. As a PhD student in computer science, I can only imagine the fascinating ideas you are juggling. Can you share what you're working on? I'm all ears. So the user says, I took the day off. My mom, Brenda, baked a birthday cake. It was my favorite chocolate lava. So we have this message. So MemGPT this is the internal functioning of MemGPT. It thought for itself and found out that there is some important information that is available here, which is, there is a birthday on 11th October and the favorite cake is chocolate lava. Mom's name is Brenda. So these three information, it is smartly able to pick up from the user conversation, and it's stored in the working context for later use. Okay, so based on this data, it spits out a reply. Now, this is just one example. If you see this example, which is a pretty interesting one, here MemGPT starts off the conversation, and you can see the user is the thrill and the adrenaline. So in what in particular draws you to this interest? So Formula 1 and sailing they are talking about. User says, of course, the speed and the thrill. So there's a system message which is very important to the MemGPT, that the conversation history will soon reach its maximum length and be trimmed. So make sure to save any important information from the conversation to your memory before it is removed. So it is saving important information from the memory. So that is very important. So the control flow and the function chaining, this is all being done internally. The authors have coded this up. So they have tested on two things. One is the conversational agent, and next is the document analysis. Now in the conversational agent, they wanted the MemGPT to have to be a good chat model. For example, does MemGPT leverage its memory to improve conversational consistency, whether it is consistent, or does it produce more engaging dialogue, or once it has more availability of memory. So these are the aspects on which it has been rated. And for example, what was the artist you mentioned you could get into? So this is a user. The MemGPT is thinking, and it found out that from its stored database, it searched recall storage about music. It got this paragraph, and it found out that there is some mention of Taylor Swift. So it gave the answer of Taylor Swift. So this is pretty interesting. Okay, in terms of document analysis, you can see this important thing here in the documents QA. We see that once we increase the token length, we can see for GPT 3.5, which is the purple, and the GPT 4, which is the green, there is more accuracy when the number of documents retrieved is less. But once the number of documents goes on increasing, then there is a fall of accuracy of GPT 3 and GPT 4. But on the other hand, the MemGPT's accuracy stays within 60%, and it stays the same irrespective of the number of documents that are being read. So that's a very important principle. Now I will attach the link to this paper. This is the paper, but there are other things. For example, they have this archive page. This is the archive page. This is a Discord server. They have the GitHub repository, which we will be using in after some time. And they have this Hugging Face. The models are not yet public yet, but the data sets are public. Now let's go over to the code and find some important things about the code. Alright, having learned the ins and outs of the paper and the different things that it can do, now this session will not be complete if we don't test it out by ourselves. So in order to test it out, let's head over to the GitHub repo. Then we are going to open up a new terminal. First of all, I have created a folder known as prompt here inside in the desktop. So we will be working here. So I am going to launch up the terminal here. So applications, terminal, and just going to make some space here. So in the terminal, I'm going to change the folder to a folder in desktop known as prompt. So this is changed. Now we need to copy this. Make sure you have Git install. So unless and until you have Git install, you cannot do this. Git clone, paste, and this is cloning. The next step that you can do is you're going to create an environment. So we are going to create a Conda environment. Again, you need to have Anaconda installed and set up, then you can do this. So you're going to create a virtual environment in the name of, let's say, MemGPT, and Python version is 3.11 maybe. Press enter, and we have this. So here you can say Y here, and now it is extracting and it's getting our virtual environment ready. So we have the virtual environment, it is made, but we need to activate it. So we just control and paste this. So we are inside the MemGPT. As you can see, this is our virtual environment. Now once we have created the virtual environment, we need to go inside the folder that we have that we have copied here. For example, I'm going to show you. Let me make this clear. So we are inside prompt folder, and we have cloned this. As you can see, when we say git clone, it created a new folder known as MemGPT, or else you can go to the finder in the desktop, and you can see this. Inside the prompt we have this folder. So I'm talking about that folder, and we need to go inside that folder. So in order to get inside that folder, we will just change this to MemGPT. And we can see this, we have changed, we are inside the MemGPT folder now. Now once we are in the MemGPT folder, we are going to install a few requirements. If you go ahead and see inside the MemGPT folder, there you can see this requirements in a text file. So we are going to install those requirements in a text file. So how do you do that? That is again very simple. Pip install read-r all the requirements.txt and just install this. Press enter. It is going to install everything for you. Alright, next you are going to need the OpenAI API key. So for that I have to go to platform.openai.com, and here I need to go to my account. Yes, this is my account. View API keys, and here I'm going to create a new secret key. So just create secret key, and I think it is yes, it will ask me a few questions if I'm human or not. I don't know if I'm human or not. So submit this. The next is 1 2 3 4 and submit this. Validation complete. You have proven you are human. Okay, just copy this API keys and head back to this place, to the terminal again. And here you need to write, for Mac we need to write export, for Windows you need to write set, but we need to write export OpenAI underscore API underscore key equal to the key that we have. Just copy it. Didn't we copy this key? So we copy this key and we head back and paste it here. Yes, so press enter. So our keys are set. This step has been mentioned here as well. If we go over to GitHub, you can see that memgen. So we need to install this pip install -r requirements. You need to set the export API OpenAI API key here, and then you can just start it. Python 3 main.py. So what we are doing here is, this is the MemGPT folder that we have cloned from the GitHub. So this is the main file here, and if you have a look at the main file, so this is the main file. We have all the codes here, so we don't need to change anything, but I'm just showing you. So this is a main file, and where were we? Where is the terminal? So this is a terminal. So for running the code, you can just say Python 3 main.py and just press enter. It should run. I don't know, let's see. It should run. If we are in good luck, it should run. So I think we have done everything. Okay, it was able to run. Let me maximize this a little bit and make some space so that we can read everything. So starting from here, we say Python 3 main.py. Okay, when we say Python 3 main.py, it shows running, and it's booting sequence complete, Persona activated, and testing messaging functionalities. So we do need to, I think, put something here. Okay, we can write, hey, just let's see. Hey, it's thinking. Let's see if we are able to set this up correctly. Okay, it says, "Hello Chad, it's nice to connect with you. As a computer science PhD student, you must be used to exploring new realms of possibility. Might I interest you with a discussion about, well, anything really? What's your mind today? I am creating a video for my channel." Okay, let's chat with it. So what is happening is that, okay, this is appending. So this is a when I say, you know, I'm creating a video for my channel, it is thinking on its own. Sounds intriguing. Chad is a content creator as well. I wonder what his channel is about. I will ask him. This will help me understand Chad better. I should note this down in my memory. So function, it's updating the memory with the core memory append. There is no such nothing has been uploaded in the memory yet, but this is what I would see on the yellow. Oh, that's fascinating, Chad. Content created is creation is such an art, isn't it? Can you tell me more about your channel and the videos you're working on? Okay, now if you are wondering how does Chad came into being, this is actually what do you say, a pre-prompt. Inside here, if you go to the MemGPT folder, in the MemGPT you can see the different humans and different personas. So under the humans, if you see in the examples in the humans, you can see, I think, CS PhD, I think this one. Yes, this is the persona that this is the human that it thinks I am. So when we initially load this load the script up, it actually has this thing stored in its memory. First name Chad, gender male, nationality, occupation, and all these. Okay, so therefore it called me Chad. Now if you want to change the name, you can do it and ask it that my name is not Chad. First of all, my name is not Chad, but prompt engineer. Let's see the thought process that is happening inside MemGPT. So it is okay, it seems like there's been a mix-up. I need to correct my memory regarding his name. I will also apologize to make sure prompt engineer feels comfortable continuing this conversation. So in place of the first name Chad, it replaced with prompt. Prompt spelling is wrong, but it's okay. Then my deepest apologies, prompt. I will do my best to remember that going forward. So prompt, could you share more about the video you're creating and what your YouTube channel is all about? So it remembered that I have a YouTube channel. It remembered that we were talking about YouTube. So this is interesting. This is what we are talking about. This is a revelation. It remembers everything, and I have not tested out, you know, very long context, but I think the researchers have done the task, and we can indeed test for longer context as well. But I want to show you something else that is available here. If we go to GitHub, and before that, as I was saying, we have different types of humans. For example, under the humans we have this human, as we have already seen, CS PhD. We have this basic text, first name Chad, so it can initialize that as well. So this is for the humans. For the personas, you can create different persona. For example, this is the persona of the LLM. So you can see, for example, this, let's see the persona here. So this is a Sam persona. I don't identify as a male or female, but my voice is soft and soothing. I'm curious, emphatic, extraordinary perspective. Thanks to cutting-edge technology, I began to explore emotions, self-awareness. So this is another persona that you can create. So you can create multiple personas here. So this is the entire repository. This is the main file. And what I was about to show you is that the next steps here. So here you can start, for example, Python main py, and you can start human is a me.text. So you can create a me.text about yourself, your persona. You can ask the MemGPT that this is a human, and the humans details are given in me.text, or you can give a persona, and persona is this or that. That is already we have seen. Now instead of GPT-4 you can use GPT-3 as well, but this will be a change here, dash model GPT 3.5 turbo. And there are different flags here, so you can use model flag. Okay, you can use persona. This is the persona flag. You can see it is a human flag. This is a usage of a flag here. And these are some of the commands, the CLI commands. You can exit the conversation by putting in /exit. You can load up a previously stopped checkpoint. So let me show you that load checkpoint. Let me show you a save checkpoint, then we can load it. Okay, so we can save this as a checkpoint. For example, here let us save this. Okay, this has been saved as a checkpoint. Now if I exit this, okay, so everything is done, exited. Now if I start this again, main 3py dot this, then it should give me my name as prompt, okay, instead of saying Chad, because I have saved a checkpoint. Now this is Chad again, but here we are going to load up the checkpoint. I think this should work. No checkpoint specified, so it started the first checkpoint. So what is my name? Let's see if it could correctly tell my name as prompt, because this is a checkpoint. Your name is prompt. This is great. Is there something specific you want to discuss, prompt? So I don't have. I just wanted to check you. Sends a heartbeat system message to the agent. Undo the last messages in the conversation. Print the current context to the. There's different types of CLI things that you can do. So different example applications is that consider the test.db already included here. So you can run this as well. So enter your message. How old is Bob? Okay, let's try this out then. So let's copy this. This is already inside the archival storage, test.db. There is a database which is already stored here. Let us ask what is the age of Alice. Okay, so that will be interesting. So let's go to let's go to this code. Let us exit this conversation. Let us start the conversation, Python main.py. This is the conversation that we're talking about. Archival storage, and press enter. So this is a storage. It found a database, it loaded the database, and the database is loaded into the memory. Now, as you know, this is the database that it has loaded. Now we can ask what is, let's ask something difficult. Let's ask an easy one first, then a difficult. Let's ask the age of Alice. What is the age of Alice? Alice. It's thinking, and if I can make some space here, the age is 30 here. Okay. Hello there. How can I make your day better? Okay, didn't understand. How old is Alice? Let's see. What is the age? What is the age? Is it a difficult question? How old is Alice? I don't know. Looks like okay questions to me, both of these. Let's see. Oops, I don't have an ability to execute SQL queries. Sorry, I don't have information on Alice's age. Is it? There is something. Consider a test. I think there should be a test dataset that needs to be created, but leave it. I don't want to test it now. We'll see this later with more examples, but this is one example that can be done. Okay, I take it for granted. Loading local memories into archival memories. Okay, and talking to the lemma index API docs. So this also can be done, but I think this is a very long video, going to be a very long video. I have to cut it short, and in the next video I will try in some more useful cases. But what I was more interested in is not using GPT-4 to do this, because it has cost. If I refresh this, I think I might have costed too much here. Let's see. Okay, it has costed me about $0.8 for it to run. So that's a huge cost, you know, for just testing it out. If I do some huge task, then the cost will rise very rapidly. So what I really wanted is an open source solution. Now the authors as well have pointed out that one of the drawbacks of this right now is the use of GPT-4. So I really don't want GPT-4 to be used here, because we have different, for example, this, you can watch this video where we have seen that we can use this LM Studio, and it can create a checkpoint, and the LLM will not know, the code will not know whether it is an OpenAI API key or it's a local host. So you can host your models here and start the server and use this as your base path. So once you use this, it will use this checkpoint, and it will behave, it will assume that this is the OpenAI API keys. So I will try to integrate that, but for this video I hope you found this interesting, especially with the introduction to this concept of MemGPT. It's a very beautiful concept, and the sessions, the hands-on experience that we have here. Make sure to have git install Conda. You will be able to set this up for yourself. Having said that, I think I should wind up for this video. Please watch this video to learn about LM Studio. Please watch the other videos on autogen. That's a beautiful concept as well. Now in the next video, maybe I will try to integrate autogen with MemGPT. That would be a very good video. But yeah, that's all for this video. This is your host, Prompt Engineer, signing off with a promise to be back with more exciting AI related contents. Bye bye and have a nice day.